Thank you for joining us. My name is Lena Gurman. I am the founder and CEO of STEM Santa Fe, and we're happy to come on live and try to show you a little bit of what we do. With me is Bharath Korap. How do I say your last name, Bharath?
Kurapati.
Karapati, yeah. Bharath and I are going to demonstrate for you a small piece of what we do with one of our in-school programs called STEM Scaffold Santa Fe. This is a high school program, hands-on, and where it involves engineering and coding. And the project we're working on right now is a one-way bridge. And this program usually takes about 12 to 16 hours of instruction, and the students build the projects with circuitry and with Arduino boards. But since we are virtual, we start with a simulation of how to build this project on Tinkercad. And today, Bharath is going to show you how he builds a, what is it, social distancing
Alarm.
That's it. All right. So I will let Bharath take it from here. And if you have any questions, put them in the comments and we'll ask them.
Okay, cool. So before we start building this, I just want to make sure we know what a social distance alarm is. So by the CDC guidelines, we know that we have to stay within 6 feet of each other. And what this alarm does is it detects when someone enters your 6 feet bubble. So in order to construct this, we will need a resistor, an LED light, an Arduino board, and we will need an ultrasonic distance sensor. Okay.
I just want to mention that this is done online on a browser-based application called Tinkercad. Anybody can create an account on tinkercad.com.
So we're going to start off by connecting the resistor to the LED. All the resistor does is it controls the flow of electricity to the LED. So it just has right enough power so your LED does not blow up. So we're going to connect our LED to our ground. We will make it black so we can color code and keep track of what wires do what. And we will connect our anode of our LED to the trigger pin 4. And we need to give the ultrasonic distance sensor power and ground. So we're going to use the 5 volts that's built into the Arduino and connect it to our ultrasonic distance sensor. We're going to do the same with ground. All right, and then we need to connect 2 more things or 2 more pins, which is the trigger and the echo. This is where the code is transmitted through and is functioned through in the Arduino. So we're going to connect our trigger pin to 12 and our echo pin to 11. And we'll change the colors as well. Now we have our circuiting all set up. So we're going to drag this to the side a little bit and open up our code. Now, in order for this to work, we have to code it. So we're going to start off by creating a variable. This variable will be distance. And in order for us to do something with distance, we need to set it to something. So the ultrasonic distance sensor will detect how far an object is away. So we want distance to read whatever the ultrasonic distance sensor is detecting. So in order to do that, we set distance to read ultrasonic distance sensor. I'm going to drag this out so you can see it a little more. And we're going to include the pins that we have on our Arduino. So we did 12 and 11, and we'll change our units to inches. Now we have to do the main logic behind the code. main logic uses these if then else statements. And how we're going to do this is, so we want it to do, if the ultrasonic distance sensor is reading below 72 inches or 36 inches, we want the light to flash. In order to do that, we go to our math, grab one of those equations. We're going to put distance as our first variable. We'll set our other as 36. Now, if distance is less than 36, we want the light to flash. And how we make the light flash is we get our set pin. And since our LED is connected to set on pin 4, we're going to set pin 4 to high. All this does is turn the light on. If we want it to flash, we will make it wait 0.5 seconds, and we will get another set pin 4, and we'll set that to low. So all this is doing is, if our distance is less than 36, the light will flash. Now this else statement. So if someone is not within your bubble, then we don't want the light to flash at all. So how we code this is, all we do is in our else statement, we set pin 4 to low, meaning off. So now if we simulate our circuit, we should see that the person, this circle thing represents a person, and we can see that it is 44.7 inches out. And if we drag it in to under 36, we can see that the light is flashing. If we drag it back out, the light stops flashing. And that is the social distance alarm.
So, Bharath, so would that be something that then you want to give you you would have an actual Arduino board and ultrasonic sensor, and you build this circuit, you can like put it in a box and put it in your pocket, for example?
Yes, you can use this in a real life application. All that would be necessary is the ultrasonic distance sensor is reading where you want it to read, and it is not covered by any object. And when someone enters your 6 feet bubble, the light should start flashing. And when you see the light flashing, you know that someone is within, and you should probably have your mask on.
Cool. And if you zoom in on those pins, I just want to kind of see the pin numbers as they relate to the code. So you've got here, okay, so this coding method is called block coding. And so instead of writing syntax and text commands in words and numbers and letters, you actually drag and drop and connect those blocks together, which makes it easy to learn. And it makes it easy to learn by middle school students and high school students who do not know any coding. With what this is teaching them is just how to think like a computer would think and write the commands for it, right?
Exactly.
Cool. Do you want to show them how it works, or do you already show them how it works? Do you want to show them what other extensions you could do? This is a simple circuit, but like we were saying, is that students start by building these circuits on Tinkercad, and once they master it and once they can see that the simulation works, then we give them the actual board and parts and resistors and lights, and they build the actual project. And this is one of many, many projects, just the simplest one.
So a more advanced application of this project would be a lower phase shield. And what the lower phase shield does is the same aspect of signifying when someone is within your 72-inch bubble. And instead of only just alerting you, it will also lower a phase shield using your servo motor. And the way this works is that if I start my simulation, so I'm going to drag it all the way out. So we can see that the servo is exactly at 0 degrees, meaning no one is within your bubble and none of the lights are on. But as soon as you drag it Below 72, the 6 feet guideline, we can see that a red light is on. And if we drag it even more down past the 32, the face shield, or the 36, the face shield turns, signifying, and the blue light turns on, signifying that someone is within 3 feet and your face shield needs to be on. And if we drag it back out, everything goes back to normal. And this is
that's pretty
coding.
cool. That's pretty cool. So you can have, you can have a face shield that, on your head, and it'll come down just automatically when someone comes close, huh?
Exactly.
I need an alarm that would remind me to get my mask from my car when I'm hopping out quickly and I forget it. So this is awesome, Bharath. Thank you so much. Bharath is a senior in high school who's actually taking some college classes, and he's graduating this year, and he's one of our mentors for other high school students. And we provide this program to Northern New Mexico students in school, during school time. I don't see any questions, so I think we're gonna move on to doing the raffle now. And the raffle is for this water bottle, this STEM Santa Fe stainless steel vacuum double-walled, really great water bottle. You can put water and ice in that, and I put it in over the summer. I forgot it in my car, and I came the second day and the ice and water was still in it. This is mine. You'll get a new one. And so I think we have 6 people that entered our raffle. I should double check just to make sure that nobody signed up in the last minute for the raffle. It doesn't look like it. So I'm going to share my screen now where I have the names. Let me first set it up here. Here we are. Okay. And here we are. And so we are ready to spin the wheel, and let me just double check one more time. Okay, it doesn't look like anyone. Here we go. And here we go. We're going to spin the wheel to see who's going to win out of those people that signed up. Spin. And the winner is Nathan Silva. Okay. Well, congratulations, Nathan Silva. I will contact you by email so you can receive your prize. Thank you, everyone, for meeting with us tonight. And again, one last time, I'm checking if there are any questions. I don't see any questions in the comments. And we promised you 15 minutes, so this is it. Just quickly, STEM Santa Fe is a mentorship organization. We have a network of STEM professionals who volunteer with us, and they serve as mentors and role models. We also organize programs that are project-based and hands-on, in school and out of school time, and we mainly serve Northern New Mexico students. Thank you for being with us, and have a great day.